Machine learning is a powerful subfield of artificial intelligence that enables computers to learn and make decisions from data without being explicitly programmed for every task. Machine learning is a subset of artificial intelligence. While AI encompasses all techniques that enable machines to mimic human intelligence, machine learning specifically focuses on algorithms that improve through experience. The core concept is simple. We feed data into machine learning algorithms, which then identify patterns and learn to make predictions or decisions without being explicitly programmed for each specific task. There are three main types of machine learning, each with different approaches to learning from data. Supervised learning uses labeled training data to learn patterns. For example, showing the algorithm thousands of photos labeled as cats or dogs to teach it to recognize cats and dogs in new images. Unsupervised learning discovers hidden patterns in data without labels. It might group customers by purchasing behavior or find unusual patterns that could indicate fraud, all without being told what to look for. Reinforcement learning learns through trial and error, receiving rewards for good decisions and penalties for bad ones. This is how AI systems learn to play games, control robots, or optimize complex systems. Machine learning powers countless applications we use every day. Email systems filter spam, medical systems assist in diagnosis, cars are learning to drive themselves, and financial systems detect fraudulent transactions in real time. The ultimate goal of machine learning is to automate decision-making and prediction tasks. By leveraging the power of data, we can create systems that continuously improve and make intelligent decisions without constant human intervention. Machine learning can be divided into three main types, each with different approaches to learning from data. Supervised learning uses labeled data, unsupervised learning discovers patterns in unlabeled data, and reinforcement learning learns through trial and error. Supervised learning is like learning with a teacher. The algorithm is given labeled examples, input data paired with correct answers. It learns to map inputs to outputs so it can make predictions on new, unseen data. Image classification is a perfect example. We show the algorithm thousands of labeled photos. This is a cat, this is a dog, this is a bird. The algorithm learns the patterns and features that distinguish each category. Another common supervised learning task is regression, where we predict continuous numerical values. For example, predicting house prices based on features like size, location, and number of bedrooms. Unsupervised learning is like being a detective. The algorithm receives data without labels and must discover hidden patterns, structures, or relationships on its own. It's about finding what we don't know we're looking for. Clustering is a popular unsupervised technique. Imagine a company wants to group customers for targeted marketing. The algorithm analyzes customer behavior and automatically groups similar customers together without being told what groups to look for. Another unsupervised technique is dimensionality reduction. This simplifies complex data while preserving the most important information, like reducing 1,000 features to just a few key dimensions for easier analysis and visualization. Reinforcement learning is like training a pet with rewards and punishments. An agent learns to make decisions in an environment by trying different actions and receiving feedback in the form of rewards or penalties. Game playing is a classic example. An AI learning to play chess starts by making random moves. When it wins, it gets a positive reward. When it loses, it gets a negative reward. Over time, it learns which moves lead to victory. Robotics is another powerful application. A robot learning to navigate a room starts by bumping into walls and furniture. Each collision gives negative feedback, while successfully reaching the goal gives positive feedback. The robot gradually learns the optimal path. Each type of machine learning has its strengths and is suited for different problems. The choice depends on your data and goals. Use supervised learning when you have labeled examples, unsupervised learning to discover hidden patterns, and reinforcement learning when you need to optimize decision-making through experience.